Now we're going to talk about how we test the data or put it on trial. So, the assumption of innocence of a defendant in a trial is like the null hypothesis. We cannot find the defendant guilty, the alternate hypothesis, unless we have evidence. So, what does evidence look like? Well, it means that you have to find data that is highly unlikely if the null hypothesis were true. So, I'm going to tell you a true story. I was jury foreman on a trial, and the defendant was accused of kidnapping and assaulting two people who had been found tied up with zip ties and duct tape. After the trial, you don't talk to each other about, oh, are you voting guilty or not guilty? You're supposed to not talk at all. But after the trial, as we were coming to our verdict, I found out many of the jurors thought he was innocent until the police showed a video of him at a Walmart buying zip ties and duct tape at 2 a.m., only a few hours before the assault and kidnapping, and kind of in the area where it occurred. The jury quickly found him guilty when they had been prepared to say not guilty before. So, what are both hypotheses? One is the defendant is innocent of the kidnapping and assault. The alternate is that he is guilty of the kidnapping and assault. So, which one did we reject? We rejected the plea of innocence. Why did we reject it? Well, I've actually asked this question in my class before. I was like, how many of you have bought zip ties and duct tape? And when you have a bunch of seniors, some of them are doing physics projects, and I will actually find a kid or two or three, 10 or 20% of my kids would have bought zip ties and duct tape together in the last year. The first time I taught this lesson, I had a kid who had just bought it 2 weeks beforehand. But what is the probability if you're actually innocent that you're going to buy it at 2 a.m., just right before the kidnapping that you're going to be accused of? It's very low. So that's why we rejected the null hypothesis, which was the claim of innocence. So, our conclusion, we can make a conclusion that we have sufficient evidence to reject the null hypothesis if the probability of seeing what we saw is very low, given that the null hypothesis is true. We can then say that we have convincing evidence for the alternate hypothesis. When we do a test about proportions using this method, we call it a one sample z-test for p. So make sure when you're writing your plan, that's what you're putting down. Now let's go ahead and do an example with smoke detectors. A 1996 report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all Americans' homes have at least one smoke detector. The city's fire department runs a public safety campaign about the smoke detectors. They want to determine if the campaign has raised the local level above the 90% national rate. Building inspectors visit 400 randomly selected homes and find that 376 have smoke detectors. Is this strong evidence that the local rate is higher than the national rate? Now, some of you might be tempted to say, oh, let me just calculate the proportion and compare. Well, it's more complicated than that. So first of all, we want to test the null that if nothing changed, let's say they were unsuccessful, that the rate is just 90%. All right. But they're actually trying to raise the rate. That's a greater than, that's our alternate. So our alternate hypothesis is p is greater than or greater than 0.90. Remember, our null is almost always the equals one, and our alternate tends to be the other one. All right, and it doesn't hurt to say, what does this p stand for? Where p equals the true proportion of homes in the city with a smoke detector using alpha equal 0.05. And alpha, that was, I'll get into that later when I actually run the test. All right, so first of all, we have to identify our method and check our conditions. Remember, we're doing a one sample z-test for p. And the first condition is the random. Well, they told you right here, 400 randomly selected homes. So that's given. Then 10% condition, let's see, they did 400 homes in a city. It's reasonable that 400 is less than 10% of the homes in the city. Now, I don't know this to be true, but it seems pretty reasonable that it is. All right. And the large counts condition And P is the number of successes, and I know that 376 had smoke detectors, and Q is the number of failures, the rest did not. And both of those are greater than 10, so my large count condition is satisfied, and I can use a normal distribution with the one sample z test for P.